Now, volume versus temperature. Let's say we have volume. Let's say we have temperature down here. All right. What's going to happen to our line? It's going to increase. And I'm doing it like this so you can see that whole best fit line right here. Are all my points right on that line? No, no. But I'm doing what's called a best fit line, where I'm drawing my line through the average of the points. Tell me about scatter plotting. Right, this is not scatter plotting. Scatter plotting relate to this? Not that I know of. Now, let's do a problem here. Example. Yes, Chase, you should. Okay. Oh, here we go. Here we go. We have a balloon with a volume, write this down, of y'all remember what that KPA stands for? What did I say it was? Kilopascal. Pascal was a scientist, and they named the pressure unit was named after his work. As the balloon, I'm going to write HE. What does HE stand for?
Helium.
It's the symbol for helium, right? As the helium balloon rises, now this refers to what Cole was asking about earlier. As the balloon rises, where's the balloon going to? Up in the sky, okay? The pressure, what happens to air pressure? Increase or decrease? It decreases. It drops to 97 kilopascals. What do you think I want to know? I want to know the new what? Volume, pressure, temperature. They gave me an original pressure and a final pressure. They gave me an original volume. They probably want to know the final volume, right? All right, here we go. We're going to set this up just like we did on the last one, and then we'll be ready for tomorrow. All right, let's go with Mackenzie. What's the original pressure of our balloon? What? What's the original pressure? Oh, pressure. Okay, you're looking at, liter is a volume, right? It's this. This is our pressure unit right here, KPA. So my original pressure is that 101 kilopascals, right? All right. What's my initial volume when I start out with this fancy balloon? 2.0. What color y'all think this balloon is? Red. All right, let's draw the red balloon. All right, there's my red balloon. It's at 2 liters and 101 kilopascals, KPA. All right, now, when the balloon goes higher into the sky, there's less pressure, okay? We have 97 kilopascals of pressure. All right, do you think that the balloon will get larger or smaller?
Larger.
It's going to get larger. When we talk about pressure, we're talking about oh my goodness. You know what is going, you know what, I'm making another mistake. What's my mistake here? Well, let me think. I'm thinking about Charles' law, but you can tell here, what law is this if I'm doing P1, V1, P1, V1. This is Boyle's law, okay? This is Boyle's law. So if I'm working on Boyle, no, there's actually not a mistake in the problem. I'm just thinking about it as being a Charles law problem, but I just pulled a problem out of the book. It's a Boyle's law problem. So now, if my pressure goes down, will my volume increase or decrease? We'll go back to what we learned here, all right? They're inversely related. So if my pressure is decreasing, then the volume should increase, right? Okay, so now we don't know what it is, but let's go ahead and solve, all right? P1 V1 equals P2 V2, all right? So I'm going to rearrange and solve for V2, right? Oops, well, what did I do wrong here? Look at that. That's not going to get rid of V2, is it? Yeah, I need to divide by P2, right? Divide by P2, yeah, and then that'll get my volume, V2, by itself. So now, all right, I'm going to plug in here, and P1 is what? 101, right? What is V1? 2 liters. And what is P2? Oops. Yeah, 97 kilopascals. Now, what unit cancels? kPa, kilopascal. Okay. Now, looking here, is this volume going to be larger or smaller than my original volume? It's going to be bigger because I have 101 over 97. So that's going to make this number a little bit bigger. So plug that into your calculator. How are you going to plug that into the calculator? 101 times 2 divided by 97. Okay, so let's plug that in and see what we get. Now, you know I can do 101 times 2 is 202, right? Okay, divide by 97 equals, all right, let's go ahead and round to the tenths place. That's always a safe place to round to. So what would that be if I round to the tenths place? 2.1, okay? So my volume is 2.1 liters. And finally, is that bigger or smaller than my original volume? It's bigger. So as that balloon goes higher into the sky, all right, here's your sky right here, what's happening to it? It's getting a little bit bigger. Okay, it went from 2 liters to 2.1 liters, all right, as it rises up in the sky. All right, no, because look what I forgot to give you a Charles law problem. I accidentally did a Boyle's law problem, so we got to do a Charles law problem. Y'all need to chill out. Yeah. Say thank you for teaching me, Mrs. Milam.
Thank you for teaching me, Mrs. M.
Of course, Mr. I. Okay. All right. Now, let's talk about a balloon again, right? A balloon at, let's say we're at 200 Kelvin, all right, has a volume. Now, help me get this right. If this is Charles' law, what are the two variables that I'm trying to compare? P, V, T. Which two variables? V and T. So here's my T. Has a volume of, let's call this 1.2 liters. All right? So a balloon at this temperature has a volume of 1.2 liters. All right, do we want to make it colder or warmer? When the temperature changes to what? We want to get colder or warmer? All right, temperature becomes, let's make this an easy one, 100 Kelvin. What's the new volume? Those of you who are pretty snazzy at math can get this. Look at your info. What's happening to your temperatures? It's getting colder. So what's happening to your volume? We don't know yet. It should do what? It should decrease, okay? Yep. So it should go down to 0.6 liters. Very good. All right, so let's show everybody how we're getting that. Let's go up here and label this. This is your original volume and your original temperature. Here's your final temperature T2. All right, now I want the new volume that's right here. How do I get V2 by itself? What do I need to multiply both sides by? T2. Very good. Who said that? Andrew? Andrew? Yeah, okay. That cancels. So V2 equals T2 times V1 over T1. Plug it in. Plug it in. See where I am getting everything? What happens to 100 divided by 200? That's 1/2. 1/2 of 1.2 is equal to 0.6. All right, so 0.6 liters. That's okay. Do you know Isaiah? All right, who loves that? All right. Could you do it by yourself? Okay. Yes.
Is that